Welcome to Study Loop.
This is chapter 37, problem number 8. This is the problem about a spacecraft. You see the light from a ship that is blinking for 0.15 seconds. This is the time that you measure as an observer in your backyard. An officer in the spacecraft, it measures it as 12 milliseconds. I'm going to call this T naught. It's also kind of like answering the question to part A. In part A, we're asked which of these times that are given to us is the proper time. So let's remember the definition of proper time. So it is the officer's time. So the proper time would be 12 milliseconds because that measurement is taken at a point where the two events occur at the same point. So then your T naught is going to be the proper time, right? Officers, which is 12 milliseconds. Now in part B, we're asked to calculate the velocity of the spacecraft relative to Earth. In order to get there, well, since we're given the proper times, we can use the equation. The proper time equals T over gamma. This gamma factor has the information about this velocity of the spacecraft, right? So let's do a trick. We know that gamma is 1 over square root of 1 minus v squared over c squared, and we are trying to get to this v. Now then 1 over gamma is going to be just 1 minus v squared over c squared. That's what we're going to use here. So if I divide both sides by t, these are going to cancel. So 1 over gamma from here is going to be equal to t naught over t. That is going to be equal to 1 minus v squared over c squared. So if I take the square of both sides, I can get rid of the square root. T naught over t squared is going to be 1 minus v squared over c squared. Again, the idea was to isolate v out of this equation. So let's add v squared over c squared to both sides. These are going to cancel. So v squared over c squared is going to be equal to 1 minus t naught over t squared. Now, we can multiply both sides by c squared, definitely, right? These squares are going to cancel each other out. So then for v squared, we're going to have this term, 1 minus t naught over t squared times c squared. So then if we want to get to v, we have to take the square root of both sides. So on the left-hand side, we're going to have v. Then we're going to have the square root of 1 minus t naught over t. This is a t squared. And then times c. So for t naught, if you put 12 milliseconds, don't forget to convert that to seconds. And then for t, if you use 0.15, then what we have is v equals square root of 1 minus 12 times 10 to the power of negative 3 divided by 0.15 square of this term times c, then we have 0.997 c for the velocity of the spacecraft based on relative to the Earth.